All right, so here we want to simplify completely this complex fraction. And we have 2 over x plus 3 plus 3 over x minus 2 all over negative 5 over x minus 2. Remember, this is called a complex fraction because we actually see like a fraction within a fraction, right? This is the main fractional bar, but then we see these two fractions being added together here. Now with complex fractions, we want to use this property, right? If we have a over b divided by c over d, right? We're dividing fractions together, right? So we can rewrite this as a over b divided by c over d, right? But we never divide by fractions, right? What do we do instead? Okay, we have to multiply by the reciprocal, or switch and flip, right? We're going to switch this from a division problem into a multiplication problem, and then we're going to flip this fraction here into d over c. But you have to be careful, right? We can only use this property when there is one fraction divided by another, right? Take a look at this one, right? We have two fractions, right? Two fractions divided by this one down here, right? This one down here is pretty good, right? We can live with that. But what about this one? So the idea then is, well, let's combine these, right? Let's get this into one fraction. So let's go ahead and add these together, right? We get 2 over x plus 3 plus 3 over x minus 2. Now the LCD in this case, right, is just going to be each denominator, right? The x plus 3 times the x minus 2. Right, so what we want to do is we want to rewrite these. Okay, we're going to build the equivalent form of these two fractions. Okay, now you notice that the first fraction has the x plus 3 down here in the denominator, but this is the LCD. So what does that mean? Right, it means that we need to multiply this by the x minus 2. Okay. Similarly, for the second fraction, we have an x minus 2 down here, but this is the LCD, so what's missing? Right, what's missing is the x plus 3, so that's what we're going to multiply here by. At this point, right, these fractions have the same denominator, right? They have the denominator of x plus 3 times x minus 2, right? That's good. So we can combine these. Okay, so before we actually do combine them, let's just clean this up just a little bit, right? This becomes 2x minus 4 here, right? This becomes 3x plus 9, so we can add these together now, right? 2x minus 4 plus 3x plus 9. Right? Combining those terms, we get 5x plus 5 all over x plus 3, x minus 2. Now, we're not done with the problem yet, though, right? All we've done is we've just simplified the numerator, right? But let's think about that. We can rewrite this. We can rewrite this as 5 times the x plus 1. I just went ahead and factored that 5 out, over x plus 3 times x minus 2, all of that divided by negative 5 over x minus 2. But this is a good thing, right? Why is this a good thing? We can use this property now, right? How many fractions do we have in the numerator? Just one, right? So we have one fraction in the numerator, we have one fraction in the denominator, so we can rewrite this just using that form, right? So we'll write this as a division problem with a divided by negative 5 over x minus 2, but we don't divide by fractions, right? We multiply by the reciprocal. So we're going to get the 5x plus 1 times the x plus 3x minus 2, and now multiplied by the x minus 2 over negative 5. What's going to cancel out here? Well, the x minus 2 cancels out. The 5 cancels out as well. Okay, so what's remaining? All right, so you make sure you keep track of what's remaining very carefully, right? We have the x plus 5, we have the x plus 3 in the denominator, and that negative, right? Best thing to do with the negative is just stick it in front of the fraction, right? So this is going to be our final answer. It's the negative of x plus 1 over x plus 3.